What we are going to study is types of sets. We have seen the definition of sets and how to represent set. We have solved some examples also. Now we'll see what are the types of sets. There are several types of set. First set is called the empty set. Empty set. Also it is called null set or void set. From the name itself, it is clear that a set which is empty is an empty set. What is the meaning of this? Okay, let's see an example. We have a set of X. X is a student. X belongs to class 1 and X belongs to class 10th. Is it possible that a student is studying in class 1 and class 10 at the same time? Not possible. Therefore, this set has to be an empty set. Next, the number of guava, the fruit, on an orange tree. Is it possible that an orange tree or plant will have guava as its fruit? No. Again, that is empty. That set has to be empty. If we go with a basket in that garden where we only have, let's say we have apple trees and we go to pick guavas, our basket will be empty. We won't have a single guava because all the trees are of apple and we cannot have guava from them. So the basket will be empty. So that type of collection which has no element, there is no element or object, is called an empty set. It is denoted by the sign phi. This is a Greek letter phi. So we denote empty set like this, phi. So this is the first type of set which we have to deal with. Second is finite and infinite sets. For example, set of all natural numbers 1, 2, 3 and so on. The list is endless. The list is infinite, but it is well defined. This set is well defined. This collection is well defined, but the number of elements is infinite. Therefore, this type of set is called an infinite set. But if we have a set which has all the vowels in it, A, I, E, O, U, we have 5 elements. The number of elements is definite. So this is a finite set. Finite set. Empty set, we know that in an empty set we don't have any element, but we know how many elements are there. There are no elements. So the number of elements is definite there. We know how many elements are there. So an empty set is a finite set. Therefore, we can define a finite set as a set which contains a finite number of elements. An empty set is also an finite set. All other types of set, that is sets which do not have a finite number of elements inside it. It has infinite number of elements. That is an infinite set. The third type of set is called equal sets. If two sets have same elements, they are called equal sets. Same elements, so they will have the same number of elements. For example, let's say A is a set which contains 1, 2, 3, and we have B which also contains 1, 2, 3. So all the elements that are present in B are also present in A, and all the elements that are present in A are also present in B. Then this type of set are called equal sets. A is equal to B. Okay, let's say C is a set which contains 2, 1, 3. Is it equal to A and B? Think over it. Think for 10 seconds. C is 213. Is it equal to A? Try to remember, in the definition of sets only we had said that when we represent a set in this form, it does not matter whether we have placed the elements. We can place the elements as ABC or ACB. So the presentation, the sequence of elements as put up in the within the set is immaterial. So these two sets are equal. Okay. So this is equal set. We have defined how many sets? We have defined what is an empty set, we have defined what is a finite set, what is an infinite set, and we have defined equal sets. Now we will see what are subsets. We say a set A is a subset of B. This is the sign of subset. Writing like C, like this. So we say A is a subset of B if and only if A belongs to A, small letter A, capital A belongs to A, this implies that A belongs to B. That is, if all the elements of A are present in B, then A is a subset of B. The reverse may or may not be correct. All the elements of B may not be present in the set A. Let's see an example. Let's say A is 1, 2, 3 and B is 1, 2, 3, 4. Here we see that all the elements of A are present in B, but there is one element which is present in B but not in A. So A is a subset of B, but B is not a subset of A here in this case. Okay, this is clear. Let's take another example. Let's say we have a set X. X belongs to N, the set of natural numbers 1, 2, 3, 4, 5, 6 and all. And we have B. X is such that X belongs to the set of real numbers. Obviously, A will be a subset of B, but again here B is not a subset of A because there are so many other numbers, the negative numbers, the irrational numbers, all those numbers that are present in B but not in A. So this is A is a subset of B. So from here only we can understand that there are two important observations here. Every set is a subset of itself. So if we have A is a subset of A. Undoubtedly all the elements of A can be found in A. So A is a subset of A. This is first, and second, phi, that is the empty set. It is always an N. Phi is always a subset of every set. Whatever set you have, phi is a subset of that set. So phi is always a subset of A, whereas any set. So this is the meaning of subsets. I hope you have understood. There is a concept that we must understand here. This is about open and closed intervals. Open and closed intervals. What are open and closed intervals? This you must understand what are open and what are closed intervals. Let's say we have 1, x greater than 1 and less than 5. This means this and this, the lower limit and the upper limit, are not included. If this is natural number, then this is 2, 3, 4. This set will be 2, 3, 4. So this is called an open interval, and it is written as this is small bracket 1 5. This means if we say that x belongs to this, it means 2 3 4. Second is 1 less than equal to, and x is greater than equal to 1 and x is less than equal to 5. So this is represented as 1 5, this capital brackets. This is the representation. So that was, this is closed interval and this is open interval. We can have a combination also of these two. For example, we can have 1 and 5 this. So this means 1, this is closed, so this will contain 5 also. So x is less than equal to 5, but x is greater than 1. Or the reverse, we can have 1 and 5 like this. So this will be 1, x is greater than equal to 1 and less than 5. So this is open and closed interval. And one more thing about this, how do we represent it on the number line? So if this is the number line, this is 1 and this is 5, then 1 5 open interval we'll write as just small circles 1 5. This means this. But for closed circle, for closed intervals, it is a shaded dot. So this means closed 1 and 5, that is the both numbers are included. We can have combinations also. If we have 1 and like this open interval here, so we can have this and so on. So this is something that you should know. It's given in your book also, and you should know this. We'll be using it very frequently. Now we'll see what is a power set. A very important concept, that is power set, and then we have universal set. What is a power set? Let's say A is 1 and 3. So what are the subsets of this set A? First subset will be, as we know, the empty set. The second subset will be, I'm writing it here. First subset will be 5. Second will be 1. Then the third one will be 3. And then every set is a subset of itself. So 1 3. So these are the 4 subsets of this set A. If we have a set which is the set containing all the subsets of A, then we denote it like this: P of A, power set of A, and we represent it like this. So what does it includes? It includes all the subsets of set A. So a set which contains all the subsets of A is called the power set of A. Another thing is, if the number of elements in the set is, let's say, m, then the number of elements in set A is m, the number of elements in this power set will be equal to 2 to the power m. Like here we had 2 elements, so this is 2 to the power 2, that is 4. We have 4 elements here. If the number of elements in this set was 3, this was 8, and so on. So this is something you should remember. So this is power set. Another set is universal set. It is a very useful concept. Let's say we have 3 sets, A, B, C. Let this contain 1 and 2, this contain 3 and 4, this contain 1, 3 and 5. Universal set for these 3 sets will be a set which will contain all the elements of these 3 sets. That is, all these sets will be the subset of this universal set. What it will be? This will contain 1, 2, 3, 4, 5. This is repeated here. So the universal set for these three sets is this. So a universal set is a set which contains all the elements of its subsets. So there's a difference between power set and universal set. Power set, we have power set of a certain set A, where we have in the power set the elements are the subsets of that set A. But universal set, it does not contain the subsets. It contains all the elements that the subsets are containing. If we have three sets A, B, C, and they contain 5, 6 elements, then a set which contains all these elements will be the universal set for these three sets only. This is not universal for every set. This is universal for these three sets. For example, real numbers. Real numbers can be taken as universal set for the natural numbers, the integers, and the rational numbers. So this is the concept of universal set.